Hello, my name is Mr. Whiteman, and in this video I'll be talking about GCSE molar gas volume calculations. These are the equations that I'll be using throughout, and in another video I explain how to use moles equals mass over MR. Make sure you have your periodic table to hand, because if you wish to do any calculations you'll need to refer to the mass numbers, which are the bigger numbers on the periodic table. Looking at this table, I have neon, oxygen and carbon dioxide. If I were to have 1 mole of each of these gases, bearing in mind that they all have their own mass numbers, at standard conditions, which is 20 degrees Celsius and 1 atmosphere of pressure that you are experiencing, they will all occupy 24 litres if you had 1 mole of it. If I were to have 2 moles of it, it will be proportional in volume, and therefore 48 litres. A mole of any gaseous substance will occupy the same volume at any given temperature or pressure. At standard conditions, 20 degrees Celsius to 1 atmosphere, a mole of any gas will occupy a volume of about 24,000 centimetres cubed, which is the same as saying 24 dm cubed, which is similar to say 24 litres. So if I had 2 moles, again, that would be 48 decimeters cubed, or 48,000 centimetres cubed. Doesn't matter how much they weigh in terms of a substance, it will be proportional in volume if it was at the same conditions, and at standard conditions it would be 24 litres if you had 1 mole. So a quick question, if I didn't have 1 mole, but I had 30 litres or 30 dm cubed of sulphur dioxide reacting with 15 of oxygen, so 30 reacting with 15 in the ratio 2:1 to produce 2 lots of sulphur trioxide, which is SO3, what is the maximum volume of sulphur trioxide that can be formed in that reaction? A, B, C or D? Have a moment to think. If you're ready for the answer is C. A lot of people might say 45 because they will say 30 plus 15 makes 45. But all that matters is the ratio, because it's proportional. The volume of gas is proportional to the amount that you have. So the ratio is 2:2. So if I had 30 centimetres cubed of SO2, 2:2 same as saying 1:1, then I would also get 30 being produced. From oxygen's perspective, the ratio is 1:2. 1 lot of oxygen produces, when it reacts with 2 SO2s, 2 lots of SO3. 15 times 2 is also 30. So the amount of volume that I have is proportional to the big number in the equation. So if I had 30 litres of SO2, again it reacts with half that at 15 to produce 30, which is double the oxygen. But if the amounts were changed, so here are 3 equations, again you just need to look at the big numbers in the equation. If I had 100 centimetres cubed of nitrogen, it would react in a 1:3 to produce 2 lots of ammonia. So 100 nitrogen would need to react with 300 centimetres cubed of hydrogen, and that would produce 200 centimetres cubed of ammonia. If I had 45 of nitrogen, timesing by 3, because I have 3 lots of hydrogen reacting with 1 lot of nitrogen, that is 135 centimetres cubed, producing 90 centimetres cubed of ammonia, as the ratio is 1:2. If I had 100 centimetres cubed of hydrogen, that would require 50 centimetres cubed of oxygen. But bear in mind this only applies if you have gases. So watch out for the state symbol here. Can't really do that for water, because gases will change when they turn to liquids. They'll be closer to each other, and so you can't make the same assumption in terms of their density. If I had 300 centimetres cubed of hydrogen, that would occupy 150 centimetres cubed of oxygen. 100 centimetres cubed of C4H10 or butane would react with 650 centimetres cubed of oxygen to produce 400 centimetres cubed of CO2. And likewise, 60 would react with 390 to produce 240. So units are important here, so unit conversions. A decimetre, as I mentioned earlier, well, decade is 10 years, so dec means 10 as a prefix. A decimetre is 10 centimetres. Because it's a volume and it's cubed, 10 times 10 times 10 is 1,000. And so essentially, to convert centimetres cubed into dm cubed, then we divide by 1,000. Similarly, there are 100 centimetres in a metre. So if we're converting centimetres cubed to metres cubed, 100 times 100 times 100 is a factor of 1,000,000. If we're converting all the way from centimetres cubed, then we divide by 1,000,000. Watch out for the units as they can catch people out. A mole of any gaseous substance will occupy the same volume at any given temperature or pressure. And so this will be a constant value at either 24,000 or 24 if we were to have 1 mole of the substance. These units do need to be correct. You can't have centimetres cubed of dm cubed, it would have to be the same unit, otherwise it will not make sense. Example question 1. Calculate the mass of the following: 12 dm cubed of carbon dioxide. So if I have 12 dm cubed, then I'll need to use the equation as being moles equals gas over 24, the gas volume. So if I have 12, to work out how many moles I have, 12 over 24 is 0.5 moles. Then I need to add that into my other equation. Moles times mR is mass. So 0.5 multiplied by 44 will give me a mass in grams of 22 grams. Example question 2. What mass of aluminium will produce 100 centimetres cubed of hydrogen? So getting slightly more complicated, where we'll need to use 2 equations again, but in relation to the ratio of the equation. You might want to create a little table to help collate some of the information. I am trying to work out the mass of aluminium, and I have 100 centimetres cubed of hydrogen that was collected, assuming 100% conversion. This would be 0.00416 moles of hydrogen. We can get that by doing 100 divided by 24,000, as my volume was 100. So 100 divided by 24,000 is 0.00416. The ratio is 3 to 2. I know this because from the equation it says 3 and it says 2. So to get one part, 0.00416 divided by 3. To get 2 parts, then times by 2. So 0.00416 times by 2 over 3 will give me the amount of aluminium moles at being 0.00278. To work out the mass of aluminium, I then need to use the equation mass equals moles times, in this case it's AR being more technically correct, at 27. So it's important not to times this by 2. If I had 2 moles of aluminium, then yeah, I would times 2 by 27 to get the mass. But I only have 0.00278. So if each aluminium was 27 each, then I need to do 0.00278 multiplied by 27. This is a common mistake if you were to times this by 2 because you're seeing the number in the equation. We've already applied that ratio when we divided by 3 and times by 2 to the moles of hydrogen to get the moles of aluminium. So if you did this again, you've applied that ratio again. So 0.00278 times 27 gives us a mass of 0.0075 grams. Example question 3. Calculate the volume of gas produced when an excess of dilute HCl is added to 1000 milligrams of calcium carbonate. The equation is shown. So 1000 milligrams is the same as saying 1 gram. So if I had 1 gram of calcium carbonate, the MR is going to be 40 plus 12 plus 16 times 3, as I have 3 oxygens. So 40 plus 12 for carbon plus 16 times 3 gives me a molar mass of 100. I am tasked to work out the volume of CO2 gas. So to get the moles, mass over MR equals moles. So 1 divided by 100 is 0.01 moles. The ratio in the equation is 1 to 1. I know this from the equation. We don't write 1 in the equation. It being there is already 1. So 1 lot of calcium carbonate will produce 1 lot of CO2. So 0.01 moles of CO2 will be produced. I don't need to know the MR CO2, but if you were, that would be 44. Some people do this but not realising what they do next. I don't need to use that because in this question I'm needing to work out volume, not mass. And so rearranging the equation, if moles equals volume over 24 or 24,000, in this case I'll use 24,000, then 0.01 multiplied by 24,000 is 240 centimetres cubed. What will this be in dm cubed? To convert to dm cubed, we need to convert by dividing the answer by 1,000, and so that would be 0.24 dm cubed. Here's another exam question. Sodium azide is used to produce nitrogen to inflate airbags. In the equation, 2Na3 makes 2Na plus 3N2. If you'd like to pause the video and have a go yourself, I'll go through the answer in a moment. A fully inflated airbag has a total volume of 108 dm cubed. Calculate the amount of nitrogen in moles in a fully inflated airbag. So, moles equals volume over 24. The question has given me a volume of 108 dm cubed. So, 108 divided by 24 will give me the number of moles of the nitrogen in the airbag. This is 4.5 moles. Use your answer in part A to calculate the mass in grams of sodium azide, which is NaN3. The ratio is 3 to 2. I can't apply the volume of 108 divided by 3 times by 2 because sodium azide is a solid. So I needed to work out the moles, which the question made me do previously, to work out 4.5 moles. So in order to get the moles of sodium azide, I need to look at the ratio of the equation. The ratio is 3 to 2. So 4.5 divided by 3 times by 2 gives me 3 moles of sodium azide. If the MR of sodium azide is 65 grams per mole, then to get the mass is equal to moles times MR. So 3 times 65 is 195 grams, and that is our answer. Thank you for listening, and I hope that's helped. Please check out the other videos for more.